neural network without activation functions is just a linear system. No matter how many layers you stack, it reduces to a single equation. Y equals to wx plus b. That means it can only model straight lines. But the world is non-linear, like images, speech, or human behavior. To handle this complexity, we need activation functions. Inside each neuron, we first compute z equals to wx plus b. This z is called the logit, or pre-activation. Then we apply the activation function. Here, a is the neuron's output, and f is the activation function. Don't be confused, we apply activation to z, not to y, because y is the ground truth and z is an output. And now, if we apply an activation function to our previous example, we get a curved, more accurate prediction than just a straight line. Without activation, the network is blind to complex shapes. With activation, the network gains the power to fit nonlinear patterns. Now let's look at the most common activation functions. We'll see their shapes, their formulas, and what makes each of them useful. Sigmoid maps any real number to the interval 0 to 1, commonly used for binary classification. ReLU, or rectified linear unit, keeps positive values unchanged, but sets negative values to 0. It introduces non-linearity and helps avoid vanishing gradients. Later we will talk about vanishing and exploding gradients. Softmax ensures all outputs are in range of 0 and 1, and sum to 1. Converts a vector of scores, logits, into a probability distribution across multiple classes. Hyperbolic tangent maps input values to the interval -1 to 1, similar to sigmoid but centered at 0, which often helps optimization. Let's walk through a simple image classifier. After some basic prep, we fit the image into the network. Don't worry, we'll talk about those steps in the next video. In the first layer, the network computes logits, then applies ReLU to produce the first set of activations. In the second layer, from those activations, it computes the next logits, then applies ReLU again. In the output layer, the final logits go into Softmax, which turns them into class probabilities. These probabilities are non-negative and sum to 1. We pick the class with the highest probability, and that's the model's prediction. Activation functions give neural networks the power to move beyond straight lines and capture the complexity of the real world. In the next video, we'll dive into neural networks from A to Z. By the end, you'll have a clear and practical understanding. If you found this useful, support the channel by subscribing and leave your questions in the comments.